So thanks everyone for coming along. Hope you're having a great conference so far. So yeah, so what Quest is in the business of is solutions for different IT challenges, and the database part of the business, of which I'm part, and we have 5 different business units that cover security and Microsoft platform management and monitoring. We cover all of the database tools, so we cover different database platforms like Oracle and SQL Server, but also we cover more of the relatively recent emergence of commercial grade open source platforms as well, like Postgres and MySQL. So you may have some of those. But really what I'm here to talk about is, when we talk about DevOps and we talk about the need for incorporating automated processes into a much more rapidly moving pipeline so you can shorten your release cycles, it kind of just goes against the traditional way that database development is done, where you've got very linear processes, manual processes, such as testing and static code reviews. By all accounts, when I speak with customers about how long your release cycles are on, say, your Oracle database, they're talking in terms of months. At the very briefest, 3 to 4 weeks, and that's pushing it. So that doesn't really jive well when you consider the business need of getting changes out into the market quickly so the business can be more agile. And so how do you basically future-proof your database so that your database can become part of your other DevOps initiatives? So I'm not going to even ask you if you have databases in your organization. You clearly do, but to what extent are you already considering databases in your DevOps DevOps plans? How many of you have got DevOps including database already in your DevOps plans? Yeah. Some of you don't. So it looked like 3 or 4 of you said they already have. And what database platforms are you guys running on? Oracle? SQL Server, anyone? How many of you using open source platforms like MySQL and Postgres? Okay, that's about typically what we see. So what I want to talk about in this one, because I did a presentation last year on a similar subject, which was how do you bring database operations, development operations specifically, into. Now in this session I want to broaden that whole topic and start thinking about monitoring. How do you monitor database changes in your DevOps pipeline? How do you deal with performance testing of database changes before you release them into production at speed? Remember, everything's now moving much faster than it was before. So some of this stuff that you may not be doing before, like performance testing database transactions, now all of a sudden becomes important because you've got 2-week sprints. And so any prospect of things that are not going to scale are going to become a serious problem much faster than they would have done before when you had a bit more time to deal with them. And then also, what about if you have other databases, maybe some of them are in the cloud, that are offline databases or reporting databases that are based on effectively a replica copy of your mainstream database. Offline reporting databases are typically used to take the reporting load off of a main production database. So the main database can carry on servicing the needs of OLTP operations, whereas your offline reporting database is purely for people that are generating reports. How do you replicate the changes that you're going to make on your main database out to these other databases? Because now you have to think about doing that as well. So I'm going to touch on all of those different aspects. I will be doing a little bit of live demo, but obviously in the interest of time and such what, I'll try and limit that where possible, but pretty much everything is covered in the slides anyway. So I want to start off by talking about why change? What's the driver here? And we all understand the need to change the way that businesses operate in order that they can be more competitive, steal market share from their competition, grow their revenue, and just generally be much more adaptable to external changes, to what's happening in the market. But the database is the database. If it was easy, it would have been solved. This problem would have been solved a long time ago, right? Because DevOps is not new, and Agile has been around for a lot longer. So why has database taken so long to be able to move into the 21st century? So we'll talk about the challenges, what makes the database unique in the world of DevOps. But let's look at challenging the status quo. It's not actually as hard as you might think. Yes, there are risks involved because now you're dealing with the crown jewels of the business, which is your data. Your data is critical, and you want to make sure that it continues to be protected. So what I'll do then is I'll go through a scenario-based walkthrough, and this is typical of a lot of the customers that we deal with. So we haven't made this stuff up. We've been working with customers over the last 4 or 5 years on streamlining their operations and bringing database into DevOps, and it represents, the scenario-based walkthrough represents a combination of different customers and their environments and how they solve those challenges. So these numbers tell a story about DevOps, and they probably shouldn't come as a big surprise to you. There are lots of surveys out there, and these numbers are based on surveys. So 46, 21, and 19. So what they mean is that if you've got DevOps operations, then it means that you can 46% more frequent code deployment. So that's to say that you can release code changes into production 46% faster than you were before. The 21 is if you've got DevOps in your organization, it means that you are effectively reducing unplanned work and rework to the tune of 21%, which that's not a great number, but it's significant because in the world of Agile, any unplanned work is going to be hugely disruptive. You've got 2-3 week sprints. Anything that's going to be unplanned is just going to throw a real spanner in the works, and it's very disruptive and very expensive. So the key message here is with bringing database operations to DevOps is you've got to get things right first time. You can't leave things to chance. You may be tempted to cut corners, but that's not going to help you. So reducing unplanned work is critical. And 19 is the increase in revenue that was reported in the survey. This is a survey from the CA research paper, DevOps, the worst kept secret to winning in the application economy. And companies, on average, expect to grow their revenue because now they can respond to changes much more rapidly. And there are lots of other numbers. I won't throw any more numbers at you. But so in your goal to try and future-proof your databases, are you trying to do these things? Are you under pressure from your business to build, test, and release software changes faster? That is to say, database software changes. Yes, you are, I guess. For those of you that are not yet implementing database into your DevOps pipeline, do you recognize this? Are you under pressure to start thinking about bringing the database into your DevOps pipeline? Yeah? Are you unsure about how to effectively monitor the performance impacts of database changes? So you think about database code, procedural code in the database, if that's what you're using, or think about structural changes to the database schema, table changes, index changes, things like that. You've got to have some way to monitor the impact of those changes that you're going to make before they hit the production database. And once they've hit the production database, is to see whether you actually hurt the performance or made it better. You've got to be monitoring those changes now that those changes are going to be happening faster. Unclear about how to bring your database processes into your DevOps infrastructure. That really depends what you're trying to do. So if you have a lot of code in the database, like for example, Oracle database code, procedural code in the database, there may be a lot of legacy code that your business has decided rather than sort of scrap it all and start from scratch and build applications with the business logic in the application. It's actually more expedient to just keep that legacy code, but now you've got to think about, okay, how I'm going to change that with a much shorter release cycle and keep a grip of everything. Because normally with a longer release cycle, if you find that there are bugs in the code, you've got a bit more time to fix them. But when you've got 2-week sprints, you really don't. You've got to have some way to test them. You've got to test the code. You've got to be able to identify if there's a potential bug there. Because if you introduce defects into production with 2-week sprints happening, then before long, the whole thing's just going to grind to a halt. Are you concerned about the risks of making compromises in your desire to shorten release cycles? It may be tempting to say, well, all right, we were doing a limited amount of testing, but now we've got 2-week sprints, we might as well just forget it. Let's just crank the code out faster and just cross our fingers and hope that nothing's going to break. Very risky strategy. Are you worried about the consequences of automating database deployments? This is particularly poignant for DBAs. DBAs sometimes can be quite resistant to any notion of automating and potentially doing them out of a job. How many of you are DBAs? Right? Are you worried about Are you worried about your job so far as DevOps is concerned? Or are you embracing DevOps and saying, yes, I want to be a part of it? It's an opportunity, right? It's an opportunity for DBAs to really, because they know the data, they know the database. You know, they are very knowledgeable, and they should be a key part of DevOps initiatives around databases and making sure that the data continues to be protected and secured. Are you concerned about how you're going to replicate fast-moving changes to hybrid database environments? Let's say you've got some reporting databases in Amazon or Azure. How are you going to replicate changes that you've got? And those reporting databases may be on different platforms. So your on-prem database. You might have an Oracle database on-prem, but in the interest of reducing licensing costs and reducing infrastructure costs, then you're using a cloud provider and you're using a MySQL or a Postgres database in the cloud. How do you replicate changes from Oracle to Postgres, for example? You know, think about that. So a lot of challenges, right? So having looked at those challenges, you're thinking, let's just keep doing what we're doing. Well, there are risks involved with that too, right? So release delays. So you could say, well, let's just keep doing what we're doing and hope it's going to work out fine. But what's going to happen is that a lot of times where you were making changes to your application, you might have corresponding changes that need to be made in the database. And they have to be released together, application and database changes. All right? That often happens because the application is being supported by the database. So you might have table changes, some sort of structural changes. You might have some code changes that need to happen that are part of those application changes, right? So ultimately, your application changes are going to be released while those database changes try to catch up, right? Which is a big bottleneck. So release delays, inadequate testing. In your attempt to kind of push things through faster, you might be, pushing back on testing, functional testing of the code to make sure that it's doing what it's supposed to do. Does it have any defects? But also performance testing. So if I make changes to queries, SQL queries, are those changes that I make to those SQL statements, are they going to scale in a production environment where I've got vastly more data and I've got vastly more user sessions than I have in development? And then finally, competitive disadvantage. So you might want to just continue with the status quo and hope for the best, but in the meantime, your competitors are innovating faster than you are. And now your business is really worried, because if you don't reinvent yourself and bring database into the story, then you're going to be irrelevant. So we have to change. But the reason why it's hard for us to accept that this is a difficult thing to do, it's hard to accept how we're going to bring database into a typical DevOps pipeline. And if we look at the difference between the two approaches, so on the application on the top part of the screen, database release on the bottom part of the screen. This is traditionally what happens. So the application developers are checking code into source control, triggers a build process using some sort of build automation server, but they can't release their changes until the corresponding changes that are made on the database have gone through their steps. Right? You probably recognize this. This happens all the time. And so this is a major bottleneck, and the bottleneck's caused by the fact that the database process is linear. They're probably missing out a lot of key things like testing and reviews and things like that. And then by the time they actually have a script ready to give to the DBA to deploy into production, these application teams have probably been waiting 2 or 3 weeks, and they can't release anything because they need to release it together. And it becomes just a major bottleneck. But what if you could monitor and identify performance issues throughout your DevOps pipeline so that you could identify, as you're deploying changes, whether you're impacting performance at any stage, whether it's in test or QA or staging or in production, and identify if there are performance issues happening as a consequence of some sort of database change. What if you're able to develop and deploy higher quality database changes faster together with the application changes without compromising? Because that's something you really have to do. And when we look at the way that our customers are bringing database into their DevOps operations, this is what they've realized they have to do. They have to functionally test the code, the database code. They have to subject it to rigorous testing to make sure that it conforms with the necessary quality standards and it's consistent. So it needs to be much more objective ways of doing code reviews rather than being subjected to different points of view. You've got to have more of a rules-based type of system. A lot of static code reviews on the database side tend to be peer reviews, and one person's opinion is different from another person's opinion. That certainly is not agile. You've got to have much more of a rules-based system. And finally, what if you're able to automatically replicate production changes? So as you change your production environment, you can automatically replicate those changes to other database environments, whether they're on-prem or in the cloud, since everything's moving much faster. So let's show you how we do it. So apologies for the slide. This may be a little bit busy, but let me explain what's going on here in terms of this infrastructure. This is a typical sort of infrastructure that we see on the database side. So this is purely database, not application. So at the bottom, we have a development environment running Oracle 11g. That's not unusual. Sometimes we see development environments that have exactly the same version of Oracle or same database version as in production. But usually it's the other way. It's the other way around. It's usually an earlier version. But let's say, for argument's sake, it's a 11g database. The test and QA database, I'm really simplifying this. There could be other stages as well. But let's say we've got a test and QA database that is essentially a replica of production because it's doing testing. And it's staging the environment before you release into production, right? So it's running Oracle 12c. And then you've got your production system, which is, again, a 12c database. And it's supporting an application. In this particular case, an Oracle E-Business Suite application that's being used by a finance team. It could be anything. So this is just an example. All these different database environments have access to source control. There's also another database environment, a couple of database environments in the Amazon cloud that are used by analyst teams supporting the business. And the purpose of these teams is to collect data from different data sources and prepare it for use by someone in the business for advanced analytics or visualization or something like that. Okay, and in interests of keeping the operations costs down, keeping the licensing costs down, that's not running Oracle. It's running either Postgres or MySQL. All right, it's just an example of an open source database. So it's a different platform, and it's not on-prem. It's in the cloud. But we've got to figure out a way to replicate any changes that hit our Oracle 12c database in production into that environment. And then over on the right, we're using Jenkins as our build and release console, okay? And we're assuming Git is it doesn't have to be Git. In this particular case, we're using Git and GitHub as our source control system, okay? So here's what's going to happen. The production DBA is monitoring the production environment on-prem and discovers there's a performance problem. Simultaneously, he's getting reports of problems by the analyst teams around about the same time period. It's end of month reporting, surprise, surprise. So it's consistent. Every month end, these people complain about performance. And in the case of the production on-prem database, the monitoring tool is alerted the DBA to this fact ahead of time, so they know that there's a problem, okay? So what needs to happen is that the DBA needs to figure out the root cause of that problem and push any request out to the appropriate people. In this particular case, it's a performance problem that relates to a SQL execution, and the particular SQL statement involved, which is causing a spike, is actually part of it's in a code block in a piece of procedural code in the Oracle database. So it's not something that a DBA can normally fix. If it's just a regular SQL statement execution, then a DBA may just be able to tune that on the fly and everything's hunky-dory. But because it's embedded in a stored procedure, it's not that straightforward. It needs to go to development. So the production DBA then sends a message to the development team that, hey, there's a problem. We've identified a SQL statement. You need to figure out what code block it's in and fix the problem and get these changes out quickly. So either in the next sprint or a new sprint or whatever it is, you need to figure out what this change is and push it out there. Any of the changes that are made, particularly for this one, because it involves a SQL execution, really needs to be performance tested. Because you might make a change to it and it works fine in development, but in a production environment, it could be a completely different ballgame and it doesn't scale. We see that a lot. This is the sort of bane of a lot of production DBAs is, development changes not scaling when they go to production. No one's tested them, okay? But because everything's moving fast here, you can't afford to just, do performance testing on a desktop tool. You've got to have some way to fire off a job, a scalability job effectively, on the fly as part of your automation process to establish whether does it meet my SLA or does it not. And you know, if you're a services provider, you might have SLAs on your application performance, so this could be critical, and it might have financial penalties if you get it wrong. And then finally, the changes that you make in your on-prem database have to be replicated. And bear in mind that our source database is Oracle, but our target databases are not Oracle. So we are replicating from Oracle to a completely different platform. So what I'm going to do is walk you through some of the solutions that we have here that's in our database portfolio, and I'll introduce you to each one and identify what the purpose of each one is in sequence, okay? So from the left, we have Foglight, which is our monitoring solution, okay, 24/7 monitoring. It has long history, it has alerting, it can tell you pretty much exactly what the problem is on which platform. So it works with many different database platforms. Toad for Oracle is our development database IDE. It's been in use for a long time, about 20 years now. It's well known in the industry, in the database world, and it works on Oracle and a bunch of other different database platforms, including Postgres and MySQL. Toad Devops Toolkit is a relatively new tool. It enables you to take some of the development tasks that the developers using Toad for Oracle would use and enable them to be plugged into an automated process, such as what you would see in Jenkins or Bamboo, something like that. So it's basically an automation plugin to a build automation server. Shareplex is our replication tool. It's used for multiple purposes, standby, failover, backup to reporting, a number of different instances, and more recently, ability to not only replicate from Oracle as a source, but also replicate from SQL Server as a source to multiple targets, including Postgres and MySQL. Okay? And then finally, Datapoint. Datapoint is an analyst tool. So the analysts that are in the cloud reporting use Toad Datapoint to connect to different database sources, or data sources, I should say, and query data in a kind of heterogeneous sense, pull data in simultaneously from different sources into a single heterogeneous query. So you don't need to use, in the old days, analysts used to have these different tools to connect to different sources and kind of mash their data up in an Excel spreadsheet. Those days are gone. So you have a single tool, connects to multiple sources, including NoSQL sources like Cassandra and MongoDB, applications like Salesforce.com, eBusiness, you know, any data source you can think of pretty much, and pull that data in, build a query that the business is looking, so that the business person said, I need to be able to get data on this. And it could be internal sources, external sources, collect that data, clean it up, dedupe it, and then provision it to someone in the line of business to do whatever they want to do, analytics or visualizations, okay? So we're going to use all of those. So the first part is Foglight. So Foglight basically is a monitoring tool. So what happens here, the production DBA has detected a performance problem, and they've done this through a baseline deviation alarm, okay? Now you see there in the rectangular block, red rectangular block there, that's our Oracle baseline deviation alarm in red. Now it's actually monitoring other databases too. We've got SQL Server, Oracle, Sybase, DB2, MySQL, Postgres, and MongoDB. So actually monitoring all of those databases at the same time. And there are a couple of alerts, one of which is on Oracle. So that's the first point. So the deviation alarm basically is you have a nominal kind of expectation in terms of performance level. And if you deviate from that above a threshold, it generates an alarm. Okay, so that's the indication. When the DBA looks at this in more detail, they actually discover that this is a similar problem. They've seen a similar spike at month end. And if you roll back in time, you can see this happening. And when they drill into it, they discover that it's actually a poorly executing SQL statement. But because it's part of an Oracle PL SQL program, it's not something they can fix. They need to push it to development. Okay? So here we see the history graph here. So we're identifying this peak here. And on the left-hand side there, you can see there's different kind of dimensions that we can view. So it's kind of like a data warehouse with facts and dimensions. You've got different ways of looking at it. So I can look at the performance tree, and I can look at by SQL statement and get down to the table that's being accessed. So this is a table access view. And so in this grid at the bottom here, I'm saying all of the table accesses all the select statements and insert statements on that particular table and identify one that's causing the biggest issue. And you can see that it's ranked by active time percent. The next one, this is just another way of looking at it by object I/O. So now we're down to the same object, but we're able to expose the plan, the execution plan, if you will, for that SQL statement that's been identified. And we can see that the CPU cost is very high, the I/O cost is very high, and the execution time, elapsed time, is 13,000 seconds. That's a big time. That's a big bottleneck right there. Okay. Another view they can do is by module, application module, and then drill down to, say, a PL/SQL block. So that's how the DBA is able to identify something that's just suddenly appeared and drill down into, okay, where's this thing happening? I can see it's a SQL statement. Okay, now it's inside a PL/SQL block. That's not something I can do. That needs to be sent off to the development team. So, development team using Toad, what they would do is they know which PL/SQL program it is, they check it out of source control, and what they need to do then is to check which SQL statement's causing the problem, because that PL/SQL stored procedure may have multiple SQL statements in it, which is exactly the right one. They're not just going to take the DBA's word for it. They've got ways that they can check this themselves. So they make this. They isolate the SQL statement, tune it, and then what they're able to do is compare performance before and after. And then they also want to regression test the code because they're making a change to the SQL. They want to make sure that any of the use cases that they built for this particular program are not going to break as a consequence of making this change to the code. Right? You don't want to have any regression. And then finally, they're able to check in both the code and any new unit tests to form a build. So when we think of database code changes, you need to consider that it's not just the code change that you want to include in your build, it's any unit tests, because as you promote these builds, these database builds through the DevOps pipeline, you want to make sure that, for example, the people that are doing the testing, functional testing teams, not just have the code, but they have all of the tests that have been defined in the first place. They have everything they need to do their part. So I'm just going to show you in Toad. So this is Toad for Oracle. And I'm actually in an editor here. I've got, on the left-hand side, I've got a collaborative source control utility inside of Toad that lets developers basically work on the database objects and not have to worry about working with files. Normally with database IDE, most database IDEs, you have to check files out of source control into a local sandbox area and open up in the editor. Not with this. You basically work on the database object itself, and our collaboration tool, team coding, reconciles any changes you make to the object with a corresponding file and updates the file in the source control system. So it basically handles the file pieces, leaving the developer to continue just working on the objects, which would be code or tables or views or whatever. Okay? So what's happened, and I'll kind of shorten this in interest of time, but this was a stored procedure that was causing the problem. And what the developer was able to do is execute this code, which is just a simple push of a button. But what they're able to do is to switch on, different vendors have similar sort of tools. SQL Server has a profiling tool, Oracle has a profiling tool. And we leverage the profiling tool. And the idea of profiling a program is it enables you to capture information about how long each individual line of code took to execute in order to identify a bottleneck. All right, so in this particular case, if I look at the first one here, if I expand this out, you can see that it's showing me how long. So this bar chart is showing me that I've got a bottleneck. This line, this blue rectangle, is basically a bottleneck. This line of code is taking the longest time to run. Most of the time, about 99% of the execution, it's actually taking 67 seconds to run just that one line of code. So what this developer has done now is they've tuned that SQL statement. So what they've done is they've come down to the SQL statement here, and they clicked a tuning button up here on the toolbar, and it's enabled a tuning tool to basically take that original SQL statement and generate multiple rewrites. Bear in mind, database developers don't normally know how to tune code. It's a bit of a black art to them. So generally what happens is they'll go to either an experienced developer who knows a bit about tuning, but more often than not, they'll try and go to a DBA. Now think about the drive toward DevOps and Agile and sprints of 2-3 weeks. Is it really feasible to expect a DBA to, within a 2-week sprint, expect you to drop what they're doing and help this developer tune a SQL statement? I don't think so. So that's number one. Number two is, you think about the cost of tuning SQL statements in production versus the cost of tuning SQL statements in development. It's a classic hockey stick curve, right? It's going to be exponentially more expensive to deal with a SQL tuning problem like this the later you leave it in the cycle. You really need to be doing it in development. And historically, there haven't been great tools that enable developers to really get to grips with tuning. This is a very simple tool to use. You simply point the SQL statement or the bit of code that it's embedded in, and it just generates multiple rewrites. And it just takes seconds to run. So it looks at different alternatives. You can see that each of these on the right-hand side, each of these statements you see on the right-hand side in this window is semantic equivalent to the original one. In other words, it generates the same data, but it's using a different way to write the SQL statement. Sometimes it's a column order change, a table order change, or something like that that will influence the execution plan that is used at the time that SQL statement runs. And it, in an attempt to make it run faster, okay? In this particular case, we've made it run significantly quicker using alternative number one. So I can compare alternative number one to my original SQL statement, and I can look at the execution plan and see how much more beneficial that is. I've then taken that tuned SQL statement and embedded it back in my code program. And so now I've got a modified version of the same code program with a new rewritten SQL statement in it. All right so far? So how do I know that this is going to fix the problem? So what I do is I reprofile it. And when I reprofile it, I'm able to compare the performance of before and after. So if I go to my details screen here and I multi-select the original store procedure together with the tuned one, I can compare them side by side. So on the left-hand side is the execution time for my original store procedure, but now I've tuned it, I can look at the execution time for the store procedure with the tuned SQL statement, and it's significantly lower, right? So hopefully that's fixed the problem. But it's only fixed the problem in development. I don't have any sense yet of whether or not this is going to work in a scale-up environment in production, right? So that's the next thing I need to do. So just a recap, we have the ability to, one thing I didn't show you actually was, one thing you might want to do is when you actually do this, you might want to just run a regression test. So what I do here is just run this, execute it. Okay, that's run really fast. And then down the bottom here, I'm able to either build or run unit tests. So if I've got unit tests defined for this, or I might want to build a new one, what these tests are going to do is ensure that I haven't introduced any defects into the change I just made into that program. All right, so I'm going to run these unit tests and see if they're okay. Everything passed. All right, so the unit tests have been created, or I can create them on the fly. They're dead easy to do. They're stored in a repository. And the reason we do that is because for a very instance like this, I don't have to create tests again from scratch. I need to call them back and run them because I've made a change here that I want to make sure I haven't regressed anything. Make sense? The other thing is that once I finish doing this, if I was to create a new one, I'll just show you this real quick. So if I was to create a new unit test, so create new, or I can attach it to an existing test definition. Let's call it. And then let's say I can test for exceptions. I can test for, so in addition to testing a function to make sure I haven't introduced a defect, I can also test performance. So I can test on the execution time. That might be useful to do as well, since I've just hopefully changed the behavior and made it run faster. Let's see if it's still, when I run it through this, it comes out better too. So what's going to happen here is you notice that this little window pop up, it says as to VCS. So as soon as I create a unit test with a new use case or an existing, a new use case, it's going to say, this is not in your source control yet. Do you want to check it in? Now I'm using Subversion here, but I could be using Git or any other kind of version control system, right? So straight away, it's saying, okay, created a new unit test. Do you want to store it in source control with the source code? Yes, I do. So that's what it's going to do. It's going to add it to the VCS. Okay, so it's created the test case, and it's also added it into source control. And so now I'm good to go. I can check that code back in again. So just a quick recap. I'm using my collaboration utility called Team Coding to be able to check these changes in and out of source control really, really easily. I've got a way to automate the generation of unit tests and reuse them for regression purposes. I've got a way to do code reviews. So we have a thing in Toad called code analysis, a rule-based system. You decide what coding standards are important for you as a company. You select which ones you want to use. You can even customize them. And then you've got a repeatable way which can be automated. The key thing here is that because it's a rules-based system is that it's repeatable, which means it can be automated. You just need to define what rules you want to use. And you've got a really quick and easy way to tune any SQL if that's the problem. So then what we do then is, having checked it into source control, what we need to do then is incorporate those changes into our next build cycle. Okay? So for that we use Toad Devops Toolkit. And what Toad Devops Toolkit will do is basically allow you to incorporate these changes into your build process. Now I'm using Jenkins here. And so if I go to my, this is my build console, and in it I've got, I need to log in here again. No, let me go back to here again. Okay, so here's my build, and I'll have a bunch of other stuff in here on the application side, but for the database piece, I've got this. So I've got my source control management side, which, you know, I'm actually using Subversion for that. So Subversion, so I specify where the repository is located, any build triggers. So do I want to invoke this build based on a check-in action? And then down here, under here, I've got build steps. So basically with Toad Devops Toolkit now, with Jenkins, you've got a plugin that allows you to simply enter values into here to determine what you want to do as part of this build. So code analysis is basically a static code review. So any PL SQL code that's in that build gets reviewed against the standards that you've defined in code analysis. You've got your fail conditions. So you'll get an indication of whether you have met the quality requirements or whether you haven't. So you can fail the build or you can pass the build. And then down here, I've got run unit tests. So any unit tests that relate to the code that's in the build will be run as part of that build. And again, if they fail, that will fail the build. So it's pretty much the same sort of thing as you would see on the application side. And then you can add other build steps as well, just by selecting this. And there's other things that you can do as well. But that's what I've got in this particular build step. Okay. And then finally, what I'm able to do is once that build is completed, I can compare the source that's in the build to the target database I want to deploy to, and compare database configurations, the schemas, and other things, and generate basically a script which will promote the build artifacts into the target database. Okay. So you can see in this diagram here that on the left is my developers checking into source control, triggering a build. The build then basically leverages Toad Devops Toolkit, includes any actions or processes on the database side, and then generates a deployment script to enable you to release those changes or promote those changes into a target database. So that's a quick summary of that. And this screenshot actually shows the console output of that build. So this is where you would get success or failure. So that would indicate whether your build is good to go or not. Again, very similar to what you would see in an application process. And then we have the performance testing piece. So what we're able to do here is before we go into production, we establish whether the changes that we have will scale or meet an SLA by the time it gets to production. Okay? And what we've done recently is taken our scalability testing tool that's part of Toad and enabled it to be used through an API. in this case, REST API. So what you can effectively do is I'm going to simulate this by using a PowerShell script. And in this PowerShell script, I've got an SLA. And so I'm going to do a performance scalability test using Benchmark Factory. And what I'll do is I'll kick the script off. So this script is going to perform a scalability test based on a SQL statement. This is just illustrative so you can see how it works. There's my SQL statement in here. And it's just going to do a REST API call to run this test from my build process, which, as I say, I'm simulating from this script. So if I go and hit run, it's going to create a job. In a second, you'll see a job created inside a Benchmark Factory. Now, the only reason I've got the scalability test desktop console open is simply so that you can see what's going on. I don't need to do this. I've got the ability to do an API call straight from my automated build and deploy process and do this. And depending upon what SLA I have, it will scalability test whatever SQL statement it sees and determine the outcome. Is it scalable or not? If it isn't, then I need to go back to square one again and do something with that SQL so it will scale. All right, so the takeaway here is the fact that yes, you can do performance testing on database code through an API call from an automated process. You're not restricted to have to do it from a desktop tool anymore. Okay, right, coming back to, so I'll let that cook. So that's basically what I was doing. And then finally, replication. So I mentioned Shareplex at the beginning, and so having established that everything scales as according to it should do, I haven't broken any SLAs. I'm confident that this thing will scale once it goes into production. What I need to do then is, having deployed it into production, is how do I update my cloud-based databases, because they're in a different platform. And that's where Shareplex comes in. So Shareplex will look for any incoming changes, transactional changes, so data changes, basically any structural changes that are incoming into the Oracle database, and replicate them in near real time to a multiple different target database. In this particular case, Postgres and MySQL, the fact that they're in the Amazon cloud doesn't really matter. All right, so you can go on-prem to cloud, you can go from Oracle to Postgres, Oracle to MySQL, not a problem. So once those changes are replicated, what you'll find is that the people that are using those Postgres databases and MySQL database in the cloud should now see an performance improvement, because that modified SQL statement in that code block is now effectively replicated into that target environment. So by next month then, they should see a performance improvement. However, what we need to do is to check to make sure that that is the case. So one of the things that you can do in going back to Foglight again is change tracking. Change tracking gives you the potential in a DevOps pipeline to see the impact of any changes that you make during the pipeline and also after you've deployed. So what we're doing here is we can see that Foglight's telling me in the change tracking that you've modified a stored procedure. Yes, I have, I know that. But what effects has it made on performance? So here you can go back in history, look at the history view. The left-hand block is the performance that was identified in the first place, that big spike at month end. And then the second one, the blue one, the smaller one, is the effect once we've tuned that SQL statement. Right? So the performance tracking, the change tracking is showing you pictorially the before and after you made some sort of a change to the database code. And again, here you can literally compare. You can compare different dimensions in Foglight. I can actually compare the two SQL statements side by side, before, after, active time, SQL response time, and any other metric you're interested in. So you've got all the evidence you need to support the fact that the change that you made, that you identified in the first place, was successfully deployed into production, and you've seen the benefit right there. Okay? I'll share this slide deck with you, but you'll see the last two slides have some information about where you can go and get more information about our database solutions and how they come into DevOps. Definitely pay attention to this joint webcast we did with IDC, with Melinda Ballou. She's the research director of Agile ALM at IDC. So we did a joint presentation a few months ago on specifically bringing database operations into DevOps. Definitely worth having a look at. So there are two hyperlinks actually on the on-demand webcast. So if you want a copy of this slide deck with the access to these links, feel free to come and reach out to me. If you want to see any of these things working in action, come down to the Quest booth. We can show you Foglight, Shareplex, any of those other solutions that you want to see. So thank you for your time.